right? How does energy go through changes? Introduction. Has anyone ridden a roller coaster? Maybe at Worlds of Fun. The Timberwolf is one of the 2 wooden roller coasters at Worlds of Fun, and it's Worlds of Fun's first wooden roller coaster. I've actually rode this one. The coaster's highest point is 100 feet and its largest drop is 95 feet, at which point it reaches speeds of 45 miles per hour. I just wanted you to see what it's made out of. There's wood tracks. This is all wood. There's a metal rail right here. And this is all wood. Then there's the Orient Express. This was the first coaster to ever have a kamikaze curve element. This element consists of a 90-degree rise to the right or left, similar to a half corkscrew, followed by half of a traditional loop element, then a rising half loop. Then a final 90-degree dive, sending the track in the same direction it entered the element. You can see that one here. Go ahead.
How to travel with. Don't settle for incomplete. Lonix. Get more complete allergy relief.
Or we can watch. You can see it's a little older, 1980. This is the Orient Express, and this is actually the model they used to make the Orient Express. There's actually this tunnel, and then you walk through here. I've waited in lines all the way out that before. This is the building where you get on, and then you come down out of this dark hole and you climb up this long. And then right at the top, you think you're going to shoot down, but you don't. You just drop down a little and then come all the way down. And here's the corkscrew thing they're talking about. So we just compared these 2 examples to show you some of the differences between roller coasters. Some are metal, some are wood, some of the riders are above the tracks, and some riders hang below the tracks. Energy comes in many different forms. We are going to look at a few of these today. So we know energy is the ability to change something, lift an object, push an object, or simply just move an object. So in class, I'm going to take a marble that has no kinetic energy, or the energy of motion, simply because it's not moving. The marble does, however, have the gravitational potential energy, or the energy object has due to its height off the ground. So it has gravitational because it's up off the ground. So it wants to go down, but because I'm holding it, it can't. We're going to run through our vocabulary real quick. Conservation of energy, that's the principle stating that the total energy of an isolated system remains constant regardless of changes within the system. Energy can neither be created nor destroyed. And you'll see that in our future model of the roller coaster. You can see there's going to be a circle that has all of the energy in it, and it changes from potential energy to kinetic energy, back to potential energy, and it goes back and forth, but it's never created nor destroyed. So energy, what we're talking about, is the capacity to do work. Kinetic energy is the energy of motion. Mechanical energy is energy that is composed of both potential energy and kinetic energy. So your mechanical right here is both your kinetic and your potential. Then potential energy is the energy of position or stored energy. I like to think of potential energy as it has the potential to be kinetic, but right now it's just sedentary. It's just stored energy. It's just sitting there. It's waiting to move, but it isn't the energy of motion yet. All right, now you can release the marble and watch it roll down a ramp or a book or anything. And as the marble gain speed. As the marble rolls down the ramp, it lost its gravitational potential energy, which means its height decreased, but it gained kinetic energy as its speed increased. So it may have been losing its gravitational energy, but because it was going downhill at a speed, then that means its kinetic energy increased. Its potential energy was converted into kinetic energy. After leaving the ramp, the marble slowed down and rolled to a stop because of friction. The energy did not disappear, but was converted into thermal energy, which we will refer to as heat, another type of energy. If the marble crashed into anything, some of the energy may have been converted into acoustic energy or sound. The total amount of energy did not change. It always stays the same. And what do you think would happen if the marble had rolled back up another ramp? That's what we're going to investigate in this lesson by building roller coasters. But first we must understand how the energy goes through the changes. So here's the example I referred to earlier that we were going to watch. Go! We can watch this roller coaster. Starts out down there and it goes up, and you can see this is the potential energy because it's pink, and then going down it has kinetic, and see the changes. Now we can watch it through steps. Here it goes, climbing, climbing, climbing. It's building that potential energy and then stops. Right there it has no motion. It actually pauses at the top, so it's complete potential energy. And then watch as it goes down, it changes to kinetic energy. And then at the bottom, it's still completely in motion right here, not stopping. We just stopped it for the sake of looking at this. And see how it doesn't lose or gain. It just has this little sliver of potential, and the rest of it's kinetic. And then here at step 3, it's getting ready to go back up. So it's building that potential. It still has the kinetic because it's still moving, but it's building potential to make it go around again. Here it is at 4, and look here, it's getting ready to stop. It can't completely come to a stop or else we would fall out. But it has this much kinetic energy and then this much potential energy. So this is what's going to send it on its way back to number 5. And that's where it has 100% kinetic energy because it's still moving at this point. We just stopped it to watch. And then at 6, it's a little hill, but it's still a hill. So at the top, it has the stored energy or the potential energy, but it's still moving, so it has the kinetic energy. And off it goes. So that was a good example of mechanical energy. Both the potential energy and the kinetic energy are forms of mechanical energy. Potential energy is the energy of position, and the kinetic energy is the energy of motion. So imagine a ball that you hold in your hand has potential energy. It's just sitting in your hand. It has that potential to be energetic. And then when you throw it, it has the kinetic energy. These two forms of energy can be transferred back and forth when you drop a ball. Say you hold it, it has potential. You drop it, it has kinetic. You grab it again, it has potential again. So it's always back and forth. When you drop a ball, you demonstrate an example of potential energy changing into kinetic energy. And then you can play this Kahoot game, which has our vocabulary. I hope you understood this. Thank you.